In this video, we're going to be looking at taking a function that's in standard form and rewriting it in vertex form. Now, this is a pretty step-by-step procedure that you really only have to, well, follow the steps. So, we notice that in vertex form we have our coefficient outside the parentheses. So, let's just take these first two terms, and we're going to factor out that leading coefficient. In other words, the number in front of the x squared. So that's going to give me 2 on the outside, and then when I factor out a 2 from 2x squared, that leaves me with x squared. Factoring a 2 from negative 16x leaves me with negative 8x. And we're going to leave a little gap here, because there's something that we're going to fill in right here that's kind of missing. Let's leave that 34 on the outside. Now, we think to ourselves, we really want, notice, we want to have 2 times something squared. Remember, this process was called completing the square, figuring out what's missing so that you will have a perfect square. Well, we know this has got to be an x, right? And how are these terms related? Well, this was half of that middle term, so this is going to be a negative 4. What's missing then is that negative 4 squared. So negative 4 squared is a 16. Now, it's not really fair to add 16 to an equation just willy-nilly just because I feel like it. I have to keep it balanced. Now, when we were solving equations, we balanced by putting it on the other side. But here, what we can do is actually balance by subtracting. Now, I know we had the 16 inside that square, but I want you to notice something. It's not just a 16 that's being added inside that we need to subtract. This parentheses means we have 2 of them. 2 times 16, which would actually be a 32, is getting subtracted so that you have balance in your equation. So we have a positive 34 minus 32, which leaves me with plus 2. Now we can talk about all those good things that happen when you're in vertex form. We know that we're being vertically stretched by 2. We're going right 4 and up 2. So we know that we have a new vertex at 4, 2. We also know we're going to have an axis of symmetry at the line x equals 4. And we also know our graph is going to open up. So you can sketch it a lot faster when it's in vertex form. Let's do another example, or maybe 2. The next one. Let's go with, here it is. F of x equals negative 2x squared plus 6x let's not do 6 there. Let's do an 8 there. Plus 3. Okay, let's do an 8 there. I'm making this problem up as I go. Okay, so again, we're going to look at the first 2 terms and factor out the leading coefficient. So that means I'm going to factor out this leading coefficient, the negative 2. So remember, you've got to think to yourself, when I factor out a negative 2, it's kind of like dividing out that negative 2 and be left with x squared. But when I factor out a negative 2 from a positive 8, I'm going to have negative 4x. Now I'm going to be adding something here. The plus 3 is still at the end. To balance, I'm going to subtract. Here, let's put this all in the box. something. Now, it's not just going to be that number, whatever's in there. It's got to be negative 2 times that. Okay, so we were prepared to go on and complete the square. Here we go. X, half of the middle term would be a negative 2. Negative 2 squared is a 4. So I'm going to add 4 there. And I also have to balance by subtracting the 4, but it's really 4 times a negative 2 because it's on the outside of the parentheses. So negative 2 times 4 would be a negative 8, but we're subtracting it. So that turns into 3 plus 8, which gives you an 11. So what do we know? Right 2, up 11. So my vertex is at 2, 11. We also have a vertical stretch by 2, but a reflection, so the graph is going to open down. But our axis of symmetry is going to be easy. That's going to be x equals 2. Let's even do the hardest one. Ooh, I'm going to even make this one a touch harder than I did in class. Okay, so again, leading coefficient from the first two terms. Negative 0.5 comes out. And if I actually divide 3 by negative 0.5, first I'm dividing a positive by negative, so it's going to be negative. But if you divide 3 by 0.5, you actually get a 6. And it would have an x plus something. Minus 1.5. Now we need to adjust. But it's not just going to be whatever we added in this square. We have to include that negative 0.5 as well. So let's think what's going to go in that square. It's going to be x, half of the middle term, which is a minus 3. Well, now we take the negative 3 and square it, so that's a 9. So in here I have negative 0.5 times 9. That's a negative 4.5, but I'm subtracting it. So out here that's really negative 1.5 plus 4.5. Negative 1.5 plus 4.5 gives me a 3. The vertex, we move right 3, up 3, so it's at 3, 3. Our axis of symmetry is going to be x equals 3. And then we're going to open down. We have a reflection and a vertical shrink by a half.